So good afternoon, guys. My name is Vishal Vangade. I am from BCSE Government College of Engineering, Aurangabad, and today I am going to give you the PPT about very important topic in distributed database. That means fragmentation. So I got the precious guidance of our Chakravar ma'am, and so let's start. So basically, what does the let's see some basics in distributed database. So there are some three key issues in distributed database design. So first is fragmentation, then allocation, and then replication. So you know that fragmentation is what does meant by fragmentation is. So there is something called as relation, which we call as the table, in which all the tuples are stored, all the data is stored, and well, in fragmentation we divide that relation into number of small sub relations, and uh, well, decomposing a relation into multiple smaller units called fragments, and all these fragments are they must be logically related and should be correct parts. So and the next issue is allocation. So each fragment is stored at a site called as the optimal distribution. So well, that is useful in order to optimize the allocation space that is used by each fragment. And the third is replication. So you know, backupping the data. So it is same like that. So copy of fragment may be maintained at several sites. So it is called as the replication. So let's start with our today's important topic, that means fragmentation. So uh, quantitative information used for in fragmentation, this may include frequency with which an application is run. So whatever frequency with which you want an application to be run, and then site from which an application is run, and the performance criteria for transaction and applications. There are various desired characteristics of fragmentation. These include the fragmentation must be complete. That means once you finish your fragmentation and if you combine all your sub relations, then they should form your original relation. The next is it must be possible to reconstruct your original database from the fragments. So if you try to use an reassembly algorithm, then you should be able to get your original relation. That is the second requirement. Then, well, qualitative information may include transactions that are executed by applications, which include relation, attributes, and tuples. So all these must be covered by your fragmentation. So this is some sort of comparison strategies for data distribution. So various parameters are given: centralized, fragmented, complete replication, and selective replication. So you can just go through this and read all this bullshit at your home. So there is locality of reference. So in centralized, it is lowest. And reliability is lowest, and performance is unsatisfactory. Storage cost is lowest. Communication cost is high. So, well, you can read that. And then correctness of fragmentation. So how can we determine that whatever fragmentation you have performed, that is correct, that means it is performed in an appropriate manner. So there are three rules in order to verify that. So first is completeness, then reconstruction, and third is disjointness. So what does completeness means? As I have told earlier, that if a relation R is decomposed into fragments R1, R2, tick 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 up to Rn, then each data item that can be found in R must appear at least in one fragment. That means data should not be lost. Anyway, if you perform fragmentation, if there is data loss, then the fragmentation is of no more use. So, well, you must take care that whatever the data that goes into each sub relation, that all the data in the original relation must be preserved. Then the next is reconstruction. So it must be possible to define a relational operation that will reconstruct R from the fragment. So if we combine the smaller fragments, then you should be able to get the original relation. And then the next is reconstruction from horizontal fragmentation is union, and then reconstruction for horizontal fragmentation is union operation, and join for vertical. So uh, disjointness. If data item D appears in fragment Ri, then it should not appear in any other fragment. So that means all the fragments should be disjoint. That means if the data appeared in one fragment, then it should not appear in the another fragment. So there should not be any redundancy. Well, there is some exception to that. That means vertical fragmentation, where primary key attribute must be repeated to allow reconstruction, so that there will be no primary key constraint violation. Then the for horizontal fragmentation, data item is a tuple. You know that, and for vertical fragmentation, data item is an attribute. Uh, it is good if you keep that attribute as the key attribute. So the next is let's focus on the types of the fragmentation. So first type is horizontal fragmentation. So well, it it consists of the subset of the tuples of a relation. So it defined using the selection operation using the in the relational algebra, which is nothing but that sigma symbol. And you know that selection operation is going to work on only on the tuples, unlike in case of the SQL. So well, in our language, we can define the horizontal fragmentation as it is the horizontal subset of a relation which contains those of tuples which satisfy selection conditions, and it is specified in the select operation of the relational algebra. So this strategy is determined by looking at the predicates used by the transaction. So if we want to deconstruct, then we can perform R1 union R2. Then vertical fragmentation. So and then it consists of the subset of attributes of a relation, and then is defined using the projection operation of relational algebra. That means phi in relational algebra. Then, for example, you can say S1 is equals to pi staff number, position, sex, DOB, salary from relation staff. So it is going to select all these attributes, and they will be projected inside the subrelation S1. In subrelation S2, staff number, first name, last name, and branch number will be selected. And vertical fragmentation is determined by establishing affinity of one attribute to another. And for vertical fragments, reconstruction involves the join operation. Each fragment is disjointed except for the primary key. So, well, you can say that the vertical fragmentation is a subset relation which is created by the subset column, and project operation of the relational algebra is used for this purpose. So, and then the mixed fragmentation, which is also called as the hybrid fragmentation, and it consists of the horizontal fragment that is vertically fragmented. Means the data is first horizontally fragmented, and the next it is vertically fragmented. Means you are going to apply the two filters for the data. That means you can say that it is nothing but the projection followed by selection, and it is defined by using the selection and projection operations of it.